Okay, let's start this conceptual review. As usual, we're going to take notes in the Cornell style format. So make sure that you draw yourself a line on your page. Give yourself a little bit more room than what your margin can handle. And another line right here. You don't have to draw this line, it's probably already on there. But what it is you need to do over here are include main ideas that I give to you. And another thing that a lot of you forget to do are questions. You probably see me write this a lot in your notebook, or used to see me do that. So be looking for questions here. I'll tell you what the questions pretty much say on your quiz, but you're going to have to turn them into questions for these notes. So the first main idea that you're going to need to make sure that you're familiar with are mechanical waves. So your do now question, you just covered the difference between mechanical and electromagnetic waves. So you should know what makes a wave mechanical. There's two different types. So in these lectures, I'm not going to just tell you what the answers on your quiz are. I'm actually just going to tell you where you can find those answers. So there's two different types of mechanical waves. I'll give you a little hint. It has to do with the relative direction of the vibration versus the direction of the wave's motion. So maybe I'll give you that little hint. So it's all about the comparison of the direction of two different things. One is how the medium is vibrating, and one is the direction of the wave's motion. So the places that you can find this information on your pretest, take a look at numbers 9 and number 10. Now, just so everybody knows, all of this that I'm writing right here, this is not what I expect to see in your notes. What I expect to see in your notes is the answer to this question that you should be asking yourself is, what are the two different types of mechanical waves and what makes them different? So I guess over here, I'm not going to write the question for you, but I will let you know that the question should be about the two different types. And what I'm expecting you to distinguish between them is how their direction of vibration and motion makes them different. For one of them, you can say something about these two, and the other one, it's not a true statement, like the opposite is true. So check out pretests, numbers 9 and 10. Also on your do now from March 5th, a lot of you gave me the names of these two different types of mechanical waves, and you failed to give me examples. So the type of examples I was looking for were earthquakes, ocean waves or water waves, two things we should be familiar with in San Francisco. And then the other type of mechanical wave, a common form, is sound waves. So I believe I got in front of you with the slinky and showed you what these two things look like and how they're different. So it all has to do with the direction of the vibration in comparison to the direction of the wave's motion. The other thing that could help you out with this, answering this question, check out on your reading questions, or your reading notes rather. You should be looking at numbers 15 and number 16. Okay, the only other thing that hopefully some of you have checked out is the videos in the article from 226. So vids and the article, or the article, one of the two. So let me just show you what I'm talking about here. So on Synergy, this looks a little bit different for you and me. We go to our class website. Underneath homework. So 226 right here. You know what? It's not 226, it's 225. So just take a look. It's like in these articles right here, you'll get the information you need. So let me jump back to this and erase 226. We'll make that 225. So check those out if you haven't seen any of these videos or articles. I mean, it's a little bit late for you to be looking at all of them, but everything right here, this is going to prepare you for that question on your quiz. This is a 4-point question. You need to name both of the types of mechanical waves, and you need to be able to describe the difference. And again, it all has to do with the direction of the vibration versus the direction of the wave motion. Here's everything you need to answer that question. Okay, so let's move on to a new main idea. So going back to the Cornell note style format, you don't have to do anything. This is just a continuation of what you've already done, hopefully. And then make sure you add a question here. All right, so this next main idea is all pretty much about the wave diagram. It's like a 8-point question, but I've broken it into 2 parts. Pretty much what you're going to have to do on the day of the quiz is draw a wave, and you're going to have to, for the first part, just label the high point and label the low point. Tell me what it is and give me a little description. So that's all you need to do. That's 2 points right there. If you need help with this one, check out numbers 5 and 6 on your pretest. Check out the waves diagram, like I said. That's your main resource for the next 2 main ideas. Oh, and then the main idea I should tell you is just going to be, I don't know, let's say wave characteristics. That's a long word. Let's say wave properties. So the next thing that could help you is the article from 226. There's a lot in there that is covered on this question and the next. And check out number 4 for your reading notes. So I'll keep reminding you throughout this whole video, but this is not what your note should look like. What your note should look like are this I guess right here is kind of close to what they should look like, but you shouldn't be writing down these assignments. You should be writing down the information that you get from these assignments. Okay, next main idea, it's pretty much a continuation of the same main idea. So actually, let me just continue on the same page. The next thing that you need to do is draw, or not draw, but measure 2 distances. One of them is going to be the distance from the peak to the peak. You could do from the trough to the trough, but we're going to have to add some more of this wave to do that. So from here to here, you're going to need to draw this or measure this distance. You're going to need to tell me what this distance measures. So there should be a number here on your quiz. You're all going to need a ruler. I strongly advise you to stick with centimeters, but you can go with inches if you like. So tell me what this distance measures. There should be a word here, and there should be a little description stating what this is. And you can pretty much see what this is, the distance from peak to peak. Now the next distance you're going to have to draw, you're going to want to show the resting point of this wave, where this medium would be if it wasn't excited. That's going to be this distance from the peak to the resting point, or you could show the distance from the resting point to this bottom point right here. So you're going to want to draw that line, you're going to want to measure that line, there should be a number next to it. Don't forget to include your units. You're going to want to tell me what this line measures, give me a name here, and a little description. Alright, so the resources that could help you with this question. This is check out numbers 7 and 8 on your pretest. Check out your waves diagram, obviously. The the reflection, or the articles and the videos from 225. And then finally, numbers 5 and 6 on your reading notes. So leave all of this out of your notes. Just write down what you find in these resources when you take these notes. So, I mean, at any point during this video, if you want to pause it, gather these resources and start looking for the things. I mean, that's really what studying is if you go through your old resources and you locate the most important information that you're told to review for your quiz, that is essentially how to study. Okay, the next question, the next main idea. Is about the two properties. They're very closely related. So let me just try and make this take less time. Main ideas and questions over here. Make sure you have a question for each new white page I start. The last one you could ask, I don't know, about something about the wave properties. What are the properties of waves? That would be simple. Okay, so the next main idea, it's two more properties of waves, but they're a little bit more abstract. You can't see them by taking a picture, but you can measure them if you have some time. Frequency and period. The main thing I want you to know is how these two are different and how they are related. So you will have an equation on the board relating these two, but if you just write that equation down, you won't be getting any points. I need to know that you understand these conceptually. So I'm going to go over the equations at the end of this video along with the units, but when it comes to defining each of these, stating what they measure, and how they are related, the resources that you have are on your pretest. You have numbers 3 and 4. So this is where you could pause the video, get that out, and then actually start taking what should be in your notes. Oh, in your question, you could ask, how are they different? How are they related? Number 7 on your reading notes. It's likely that there's going to be some overlap in all the resources that I'm giving you. That just goes to show that you get repeatedly exposed to the same information, which is why I feel like I can hold you accountable for knowing it because you've read about it, you've heard about it, hopefully you've talked about it, you've written about it, so you should be able to show me that you know it. The waves exercises, I don't really feel like conceptually they're going to help you that much, but in my opinion, if you understand something conceptually, then you can start to apply it mathematically. So check out your waves exercises. It really won't help you with these notes, but you should have finished those exercises, and that will, once you apply those concepts, that really ingrains them. And then same thing, calculation review, everything that I just said about the relationship conceptually, not going to help you with these notes, but it should make sure that you understand these concepts. The last thing that I would suggest you take a look at is the article from 226 on your homework. You know, if you don't want to take any notes, that's fine, but if you're not feeling comfortable with the concepts of period and frequency, look on 226 right here, period and frequency. There's a video, and it's probably, let's see, maybe 5 minutes long tops. All you have to do is look at this face. Yeah, 4 minutes and 5 seconds, that's it. So check that out if you want to prepare for this question. It's a 3-point question. You need to know what frequency is, what period is, conceptually, not just looking for the equation, and the relationship between the two. So when it comes to the relationship, you could use the equation, but don't just write it, explain it. All right, moving on. Let's get a new layer here. And a new main idea. Okay, so the next main idea is all about wave interference. Okay, so I believe one of the resources that should be at your disposal is yesterday's Do Now question. Let me go to participation here. So yeah, name and describe the two different types of wave interference. So check out your Do Now from 312 to answer this question. Get that down. That should contain a lot of the information that you need. Another thing that could help you out is there's a wide range of question on your pretest. Numbers 11 all the way through numbers 15. So this isn't and, this is through. This includes 12, 13, and 14 as well from your pretest. So going back to this main idea, there's two types of wave interference. You're going to get points for naming each, and what you get, what you need to know is what do you need for each to occur. So I want to say break that down to the cause of each. So what do you need for the first type? What do you need for the second type? And then finally, I want you to know what is the effect? What happens to the resulting wave when you add these two together? More resources that you have, numbers 17 through 20 on your reading notes. So you want to check those out right now and take some notes. 228, the videos and articles. I believe this whole evening was supposed to be dedicated to learning about wave interference. So if you're not feeling comfortable, I would suggest that you go to not the instructional videos, the homework videos. 228 right here, wave interference, construct, well, I don't want to tell you that, but there's pretty much one of the answers, and interference of waves. So, check out these articles. If the videos bore you to death, or that guy's voice annoys you, we go to here, wave interference. Get some nice pictures. I believe there's even a little quiz at the end of a lot of these to help you check for your understanding, which is something that you want to do before you take a quiz. And then for this question, the last thing I would say is take a look at numbers 16 and 17 on your wave simulation. All right, the only thing else I want to do with this is, some of you have a really hard time explaining yourself. If you want to draw a picture for this one, in order to have interference, you need to have two waves. So one of these two types of interference, these two waves, if are, let's say that they overlap. In one of them, it would kind of look exactly like the other one. I mean, the height from the top part to the resting point doesn't have to be the same. But if I was to combine these two, when their peaks are in line with each other, when troughs are in line with each other, what happens when you add these two? So I believe this is covered in the videos, the articles, the simulation, the reading notes, and the pretest. I want you to say, how is the resultant amplitude affected? So this effect, I'm talking about when these two add together, what happens? Now the other type of interference, if I get two waves overlapping with each other, would be when the trough and the peak are lined up. So technically these would actually be overlapping. Like I would have to put this one on top of this one to get interference, and this one on top of this one to get this type of interference. But when the peaks line up with the troughs, and on the bottom one, the peaks line up with these troughs, what would happen? So if I overlaid these, it would look like this. But I guess the effect, what I'm talking about is, what would happen to the resulting wave, like the wave that's created from the combination of these waves and the wave that's created from the combination of these waves. Over here, when you're talking about the effect, you should be referring to either how much energy the wave has or how one of those wave properties is affected, one of those distances, the vertical one. When it comes to the cause, there's a key phrase that I'm looking for, and it just has to do with the timing of these peaks and troughs, whether they are in line with each other or completely opposite of each other. All right, so moving on to the next main idea. Next thing, that pretty much, oh no, we got to talk about standing waves. So don't forget, you need to have these two things in order to get 2 points, and there should be one for each slide that I have here, or layer. Okay, the next thing that we need to talk about are standing waves. So the type of waves where you don't see the energy moving through the medium. You just see a constant vibration of the medium. But we do have equations that relate the two, and we saw that during our lab. So I'm going to be asking you to draw a standing wave, and I'm going to tell you that it's resonating at one of the first 4 harmonics. So this might be a relatively new term to you. I believe on your due now from, it might have been last Friday. Yeah, I think it was. I showed you the first 4 harmonics. that was this picture right here. So the 6th harmonic, the 5th, the 4th, the 3rd, the 2nd, the 1st. So you're just going to have to draw one of these 4 right here. So pretty much this is one of the 3 points that you're going to have to do for that. So you're going to have to draw a standing wave, and the next thing that I want you to do is label the properties of the wave, where there's the max and the min vibration. So this isn't really a new main idea, it's like a sub-main idea. I will need you to draw one of the first 4 harmonics. Maybe you should add that in here somewhere. You need to know what this word means, or rather how it corresponds to what these things look like here. So make sure you know what the 4th one looks like, what the 3rd one looks like, or how that relates to one of those properties, which, you know, obviously the do now from this day is pretty crucial for your understanding to get this question down. So let's write that down. Do now from 3-9. Essentially, I'm going to be asking you to draw one of those 4 standing waves, and I want you to label the maximum and minimum vibrations. Another thing that could help you with this is number 16 and 17 on your pretest, and number 21 on your reading notes, um, 18 through 20 on your simulation, and the videos and articles from 3.1 and 3.4. So let me just give you an example. You're not going to have to do the 5th harmonic, but this would be, oh, the 6th harmonic. So you're just going to have to label where there's the maximum and minimum amount of vibration. But you can't just label these points and say max, min. You're going to need to tell me what these points are. And those are just vocabulary words that are in this pretest, in the reading notes, and the simulation. So check that out. Alright, so that pretty much covers all the conceptual stuff, except for the relationships. So as quick as I can, let me move through that. I'm not trying to bore you too long in class today. Hopefully you can get some studying done before you walk out of here. At least you'll have all the things that you should be studying organized. Alright, so when it comes to studying for the relationships, I think the main thing that you want to look at are your labs, the Waves labs, and you want to look at your sound lab and your simulation. So when it comes to these physical relationships, the main things, check out the sound lab. There was a lot of manipulations we made. We raised the frequency and we saw, or we looked at what happened to wavelength. That's the main one that you need to know. Make sure that you can equate the word pitch with frequency. The Waves lab, remember we were increasing the tension on the string and figuring out how the velocity was affected. We were decreasing the mass length ratio and seeing how the velocity was affected. So check out the relationships that we were supposed to learn from that. Also, in your simulation, the wave simulation, there were 2 questions where you had to draw graphs and write expressions. That was numbers 7 through 9. They all went together. And numbers 13 through 15. So lots of relationships. There's one key thing that I need everybody to take note of here. Okay, titles. I am going to give you a point for titling your graph. Now, all you have to do is read the question carefully. Hopefully you remember at this point what goes on your title. Remember, in science there's 3 different variables. At the bottom here we have our manipulated variable. And I was very explicit in the questions about which is the manipulated, which is the responding. I tell you, this is the cause, and then this is the effect right here. So I wonder if I can turn this thing sideways and still write like this. Oh yeah, that's screwing me way up. Okay, I'm gonna go crazy trying to do this. So it's gonna look even messier. Okay, forget about that. So the responding variable goes on the y. Remember, this is what causes there to be a change. This is the change that we measure. Up top here, the variable I've been telling you to title your graph is whatever is constant or what doesn't change. I am giving you a point for writing down what variable remains constant. So don't just write the word constant. Write down like frequency is constant, velocity is constant, wavelength is constant, tension is constant, mass length ratio is constant. Whatever variable is explicitly told you in the question remains constant. You're going to get 1 point for properly labeling the title. Now I usually give a point for properly labeling the axis and or properly drawing the line, like if it's directly proportional here or inversely proportional here. A lot of times people switch these 2 up, and I will give you a point if your expression matches. So if you're consistently incorrect, I give you a point. But the way that your expression should always look is you start with your responding variable at the beginning, and then you tell me that it's proportional to your manipulated variable. Now it could be inversely proportional or directly proportional. It may be in the denominator with a 1 over it, it may not be. So that's for you to know based off of you studying this stuff. But once we get in, and the other thing that you can study, and it's not even study, it's just understanding the equations, which we're going to get into next. I'll tell you every equation. But I just want everybody to be aware there's this new point, this new thing that you're going to have to do. So a lot of you might be in the habit of not reading the full question. Read it carefully and take a look. All of these are going to be in parentheses with a 4 next to them now instead of a 3, because you get 1 point for the title, 1 point for properly labeling your axes and drawing your line, 1 point for the expression, and 1 point for a sentence that tells me as the manipulated variable does this, the responding variable does that. And it would be nice if you said if this remains constant, but I'm not going to grade you down if you don't include that. Okay, last layer. We'll be finished with this video. Last main idea are the equations. This is something that I'm going to give to you. I'm not going to make you look these up. Okay. So, the main idea here are the formulas that you're going to be held accountable for. So I think what might have been helpful for a lot of you in the past is if we just write these down and then go over what each one stands for, but we won't be able to recite it together. So you will have the first formula that I gave you at the beginning of the year. I'm talking about like in August. The formula for constant velocity, the quotient of distance and time. You will need this one on one problem. You are going to have the new formula for velocity, which is the product of frequency and wavelength. You'll have the formula for frequency, which is the inverse of period. Okay, that right there will help you out with one of those other questions, but make sure you can explain to me this relationship, not just copy it off of the board. There's another formula for the velocity of a wave traveling through a string, and it depends on the square root of the tension forces acting on that string, how strongly they're being pulled from opposite ends in the opposite direction, divided by the mass length ratio. So this is the new symbol thrown at us. Mu is what it's called. And then the last formula that you have is the formula for the mass length ratio. I don't think this is a complex concept to understand how much mass there is in a given length. All right, so we should know distance, it's measured in meters, seconds, measured in time. So if I ask you for velocity, and pretty much everybody in here is going to have a question where they solve for velocity, knowing meters per second is an easy point. Over here, frequency is measured in hertz multiplied by wavelength. It's just a length, so it's measured in meters. Now how this ends up coming out, hertz is 1 over seconds multiplied by meters. Meters times 1 is meters divided by seconds, and you get meters per second. So that's why a hertz times a meter equals a meter per second. I think the new thing here is just seeing hertz times or instead of like 1 over second. So hertz meters is the same as meters per second. All right, over here we just covered what a hertz is, but it should be even more obvious what hertz are if you look at how frequency is related to period. Period is seconds per cycle. Hertz are technically cycles per second, but a cycle is a unitless quantity. There could be a cycle of anything. Just like for the transformers, there's a turn could be anything. So this is 1 over seconds. Sometimes you also see it as seconds to the negative 1th power. All right, so I think in one of our videos I showed you how this all comes out to be meters per second. I'm not going to go through that again, but we know that newtons is what measures force. And then over here, actually before I throw this in here, let's just look at it down here. Mass is measured in kilograms. We've been talking about that since the beginning of the year. Length is measured in meters. So the units for mass length ratio is kilograms per meter. If you look at the equation, it should be easy to know that. But if I ask you to solve for this, this is what you're going to need to find. So over here, newtons per kilogram per meter, but it's the square root of this whole thing. So better to just know that velocity is measured in meters per second rather than try and write this for your units. But technically you would be correct. Okay, so hopefully you're feeling prepared for the quiz, and if not, please check out some of those resources. You know, I know a lot of you have to take the quiz tomorrow, but some of those videos that I pointed out, even if you don't want to take the time, Like after going through all of this stuff, you should have a pretty good idea about what things that you're not feeling confident on. Now, if you're not going to watch any of the videos up here, at least check out the Waves review and the sound review for the Bozeman. Like if you watch these two, you'll get exposed to pretty much everything that I just talked about, other than the quantitative stuff. All right. Study hard. Hopefully you do well tomorrow or Thursday. See ya.